Hi, in this video we are going to do the hypothesis test in a different way by finding the critical region. So it says a student is told to look at 20 mathematical formulae and the teacher records that the student remembers 9 out of 20. During the weekend, the student does some revision, tests again on Monday and scores 15 out of 20. A. Using a 5% significant level, find the critical region that would enable the teacher to say there's been an improvement in the student's score. So the word improvement means it's going to be one-tailed. And state the conclusion that the teacher came to, giving reasons for your answer. Okay, so we're just doing a hypothesis test in a different way. So it says x be the random variable, the number of mathematical formula correct out of 20. And therefore x will be binomial distributed 20, and the probability of success is 0.045. So H0 is P is equal to 0.45, and H1 is P is greater than 0.45, where P is the probability of getting the formula correct. Okay, so it's one-tailed test because we're looking for a definite improvement. So, calculating the critical region. So this is slightly different to the other way of doing it. So you'll need to do a little bit of trial improvement on your calculator. So for example here, we've got the probability of x being greater than 13 is 0.058. If you want this to more decimal places, put it on, highlight it, put option F1. Where the number of trials is 20, the probability of success is 0.45. Here we've got the probability of x being greater than or equal to 14 is 0.0214, where the number of trials is 20 and probability of success is 0.45, 9 out of 20. So, writing this down, so we've got here 0.0214 is less than 0.05, and then the probability that x is greater than 13 is 0.058080, which is greater than 0.05. So you'd have to do a little bit of trial and improvement to find the actual critical region. Therefore, the critical region is this one. X is greater than or equal to 14. Since the probability of x is greater than 14 is equal to 0.0214, which is less than 0.025. So it's the first one, which is going to be less than 5%. Okay, this is on the app. If you don't have a calculator, so here is greater than or equal to 13, and here is greater than or equal to 14. Okay, here you can actually see the critical region. So the critical region is obviously going to be greater than or equal to 14, and not this one because this is too much. So, since 15 is greater than 14, this is the conclusion, we reject H0 and say that there is sufficient evidence to say that the probability of getting a formula correct has improved. Okay, so the number that they got was 15, the critical region was 14, that's better, so we will reject H0. Say there's sufficient evidence to say the formula is correct, it has improved. We'll go for the alternate hypothesis. Okay, this has been a video to show you how to do a hypothesis test using the critical region. I hope you've understood. The GeoGebra app will be in the links to this video, and you'll also find a link to my website where you'll find thousands of videos which will help you with A-level maths. Thank you very much for watching.